Let's start module number 16, which talks about planning for disaster. It's Amazon Cloud Architecting certification, and we are covering the knowledge check questions. So question number 1 says that what are the definitions of RPO and the objectives of RTO? So the best answer for this one is that RPO is the maximum acceptable data loss measured in time, and RTO is the maximum acceptable time until recovery. Think of RPO as how far back in time we can afford to lose the data, and RTO is as how long can we be down before it hurts the business. One is timestamp tolerance and the other is the clock duration of it. Now let's try to see the other answers, that why we are not accepting the other answers, as the first choice was that RPO is the maximum acceptable data loss measured by the bytes and RTO is the maximum acceptable data loss measured in time. This is not the right answer since it mixes the dimensions. RPO is time based, not size based, and RTO isn't a data loss. Then why we didn't select the second one? RPO is the target time until recovery and RTO is the average amount of time to recover. That's wrong as well because it swaps the concept and turns RTO into an average instead of the defined objective. And we are not selecting the last option, as RPO is the maximum acceptable data loss measured in bytes, whereas RTO is the average amount of time required to recover. That's wrong as well because RPO is again incorrectly measured in bytes and RTO describes as an average rather than an objective. Question number 2 says that what can you do to quickly replicate or redeploy environment in a disaster? So the right answer for that one is use AWS CloudFormation template to deploy duplicate environments in the same region. Infrastructure as a code can be used here. That would let you stand up consistent stacks fast. In disaster, redeploying from templates is the quickest solution over here, and which is a solution with the help of which we can run repeatable tasks and paths to gain the objective. Now, why we are not selecting the other answers, as it's saying over here, to use a code build to deploy application containers in a few virtual private cloud. The reason over there is that cloud build compiles builds. It doesn't provision full environment for networking. Now, the other answer, which is over here, like Elastic Beanstalk to deploy a new VPC and subnets in a different region. Now, that's also not right because Beanstalk focuses on app platforms, not full VPC subnet DR topologies. And we didn't select the option for AWS OpsWorks to rebuild the Amazon RDS instance. The reason is that OpsWorks manages stacks and it's not to go for rapid holistic environment replication. Question number 3, a company stores data in Amazon S3 bucket, which solution provides the most efficient way to ensure that all new and existing objects and metadata are copied to another region for discovery, which is DR. So the best answer for this one is to enable cross-region replication on the bucket and copy existing objects onto themselves. Now, S3 replication handles ongoing object and metadata sync. Seeding existing object triggers them for replication without custom tooling. Now, let's go through the other answers over here. For example, the first one, which says that AWS Lambda function to copy objects so that all objects create event initiate the function. That's wrong because it covers only new objects and adds operational code overhead. And then we are not selecting the second option, which says copy existing objects to the target bucket and configure clients to write new files to both buckets. The reason of not selecting is that operationally it's brittle and risks the divergence. you're now managing dual write logics, which we don't want. And then the third option was to create a workflow with AWS step function and AWS Lambda to synchronize the buckets. That's unnecessary complexity for the capability, and S3 replication already provides it natively. Question number 4 says, what strategy is the most efficient for Amazon EC2 disaster recovery? So the right answer is store essential data separately from the instance and develop rapid build processes for compute instances. Keep state out of the instance and make rebuild scripted and fast. Now that minimizes the cost while meeting aggressive recovery needs. Now let's go through the other answers like backup instances on regular schedule. It's useful but slow to restore entire image, not the most efficient for EC2 fleets. And then we are not going for synchronization of instances. The reason is that that's near to hot standby, effective but expensive and often unnecessary. And we are not going for the rebuild instances by using Amazon Machine Image from AWS Marketplace. The reason is that Marketplace AMIs aren't your tailored environment and don't address your app state. Question number 5 says that which service provides automatic failover between multiple endpoints in support of a geographical disaster recovery? So the right answer for this one is Route 53. Route 53 health checks and routing policies like failover seamlessly shift traffic between endpoints across regions. So that's why we have selected it. And if we'll see the other options like direct connect, it's not the right option since it's a private network link, not an application level failover mechanism. And we are not selecting ELB. The reason is it's great inside a region or VPC, but doesn't orchestrate cross-region DNS failovers. And we are not selecting VPC. The reason is that networking, it's a networking construct and it doesn't perform endpoint health checks or traffic failovers. Question number 6 is about which statement about the backup and restore disaster recovery pattern is true. So most cost effective but highest recovery time is RTO. So you pay the least day to day, but restores takes the longest, so downtime is highest. Now if we'll see the options, for example, if we'll go for less cost effective but lowest recovery time objective RTO, we are not selecting it because that describes hot active patterns, not backup and restore. We are not going for RPO. The reason is that while RPO can be high, the defining trade-off here is the long recovery time. So we are not going for that. And then for less cost effective but lowest recovery point objective, we are not going for that as well because it fits continuous replication pattern, not basic backups. Question number 7 is that which statement accurately describes the infrastructure characteristics of common disaster recovery patterns? So there are two answers. Pilot Light has minimal infrastructure that always runs. The rest of the infrastructure does not run until disaster occurs. And Warm Standby has a scaled down version of all infrastructure that scales as necessary and within predefined limits to meet the load when a disaster happens. Now, if we look at the Pilot Light has a minimum infrastructure, the explanation for that one is that's exactly what Pilot Light is. Only the critical core is running. Everything else is powered up when needed. And for the other answer, for the Warm Standby, we are selecting that option because Warm Standby keeps a smaller live environment running, ready to scale quickly when traffic shifts. Now, if you'll see the other options like the option of Pilot Light has a scaled down version for all infrastructure that runs until a disaster occurs. We are not taking that one because that's Warm Standby, not a Pilot Light. And if we'll go for the second option, which says Pilot Light runs with small infrastructure at full capacity, the rest scales up when the disaster occurs. We are not choosing this one because Pilot Light isn't full capacity anywhere. It's minimal core only, and we are not selecting the third option here, which says Warm Standby has a second fully functional set of infrastructure that runs all the time. That's wrong also because that describes multi-active, active, not a warm standby. Question number 8 states that what does the multi-site disaster recovery pattern involves? It involves automatic failover to a second fully functional, constantly operational system that is in another site. So multi-system means that the production grade capacity exists in more than one location and traffic can shift automatically between them. If we'll see the other options which are here, for example, the first one, it says backups are stored in different sites so that they are protected if a disaster occurs. We are not selecting this one because that's backup and restore, not multi-site. And if we'll go for the second one, which says the load is distributed across multiple geographical separated sites to reduce the impact disaster. The reason is that this hints at active behavior but doesn't capture the purpose of disaster recovery failover in this context and clearly as the correct choice. And then we are not going for the third one. Third option, it involves failover to another site that is not running until it's needed. We are not selecting this one also because that's pilot light or warm standby, not multi-site. Question number 9 says a company requires a disaster recovery solution for a business critical operation that provides a disaster recovery objective and a recovery point objective in minutes. However, they do not want to pay for more than what they need. Which disaster recovery pattern would most likely meet these requirements? So the right answer is warm standby. Warm standby keeps a smaller live environment for failover and data loss are measured in minutes without paying for full duplicate capacity of 24/7. So the other answer is pilot light. We are not selecting this one because they are cheaper, but spin up would take time, and data catch up often pushes RTO, RPO beyond minutes. And then we are not selecting backup and restore. Reason is it's lowest cost, but recovery is too slow for minutes. And we are not going for multi-site. The reason is it meets minutes easily, but you pay for full capacity running everywhere. And the last question says that what does the AWS storage gateway enable you to do? So there are 3 answers for that. Transfer backup jobs from the tape or virtual tape library systems to the cloud. That's true because the tape gateway made moves tape workflow to durable, low cost cloud storage. Second answer is it's present in cloud-based internet small computer system interface. That's a block storage volume to on-premises applications. The volume gateway exposes iSCSI block volumes to and they are backed by AWS. Then we are also using the SMB block or the NFS to connect to Amazon S3. The file gateway presents the SMB or NFS file share backed by S3, keeping operations simple for on-premises users. Now, why we are not selecting the other options, for example, connect to Amazon S3 through an API? The reason is the applications can use S3 API directly. Storage or the storage gateway is about presenting the file block tape interfaces, not acting as an API proxy. Then we are not selecting the option of providing a fully managed elastic network file system endpoint to a system in a virtual private cloud on premises. The reason is that that wording fits Amazon EFS, not a storage gateway, and we are not going for the last option, which says that it gives applications in a VPC access to on-premises block storage volume. The reason is that storage gateway surfaces cloud-backed storage to on-premises, not the other way around. So that was our course on Amazon Cloud Architecting, which is SAA-C03 code. And I hope you understood the questions with their explanations and answers. All the best for your certification exam.